Hello and welcome to your mathematical journey. So today I want to talk about like terms. And so I like to think of like terms as a numerical family reunion of sorts. So what do we mean by like terms? Well, let's take a look at this expression I've written up here. 3x plus 2y minus 5x plus 4xy plus y minus xy. It's a pretty long expression. But if we clean it up a little bit by combining some like terms, we can make it a little bit smaller. So what we're looking for with like terms is basically we're looking at the variable component of all of our terms, right? So the variable component would be x, then y, then x, then xy, y, and xy. And I like to think of those variable terms as sort of the last name, so to speak, of those terms. And what we can do when we combine like terms is think about combining the families sort of by their last name. So a helpful way you can do this when you're first getting started is to actually sort of just, draw shapes around the same last name. So for instance, we have a 3x here. Go ahead and I'll put a circle around that. This is a different last name, right? X versus y is different. We have another x term here. So I'm going to go ahead and circle that as well, including the minus 5. We want to keep track of that. And then we keep going. There are no more terms that just have the last name x, and that's important. X and xy are different last names for this purpose. Similarly, if we had x and x squared as two different terms, those would also be different last names for this purpose. So we have the x last name here. We'll keep going. We now have the y last name. I'm going to go ahead and put a square around that one, or a rectangle. Right? We have a 4xy. That's different than y. Right? We have another plus y here. So we'll go ahead and put a square around that, or a rectangle, however you want to think of it. And then lastly, we have these two xy terms. So I'll go ahead and put a triangle around each of those. And so to combine the like terms, now we want to take into consideration the numbers in front of each of the last names, right? The coefficients, as we called them previously. And we basically want to think of it as we have 3 members of the x family, and we're subtracting 5 members of the x family. Well, that makes it sound a little bit morbid, but if we take a step away from the analogy for a second, right? 3 minus 5 would be -2. So we would have -2 of the x mathematical family, not of any actual family here. No families were harmed in the making of this video. Next, we'll take this 2y and we'll add y to it. Now, here we did write 3 minus 5 is -2. Well, you might be thinking 2 plus there's no number in front here. So would that be 2y? My answer would be no. The thing that we want to keep in mind is that if we just have a variable by itself, we can always sort of put in a placeholder 1 here, right? This is sort of saying there's 1y. So 2 plus 1y would give us plus 3y. And then lastly, we have the 4xy minus xy, right? Once again, we can use this trick here, right, where we can sort of put a placeholder 1 in here. That doesn't change the value of this. And then we have 4 minus 1 is 3. So this would all simplify to the single expression -2x plus 3y plus 3xy, which is quite a bit more concise than this one up here. So once again, the idea is you want to sort of categorize them very specifically by sort of the exact set of variables they have after the numbers. Those are sort of the last names that you kind of want to group together. And then we can sort of do that for each of the different ones. You'll be able to tell if your expression has all the like terms combined, if there's exactly one term sort of with each variable last name in the expression. So I hope you enjoyed, and best of luck collecting your like terms, and math on.